The manager of a folder factory recorded the number of folders produced by the factory, and these are in terms of thousands. And the production cost in 1,000 euros for 6 consecutive months, and it's clearly shown here. Every month, the factory sells all the folder produced. Each folder is sold for 2.99 euros. So now for part A, what we need to do is, so we need to draw the scatter diagram for this particular data and use the scale 2 centimeter as 5,000 folders on the horizontal axis and 2 centimeters as 10,000 euros on the vertical axis. And this is what we need to use it. So in this one, so we need to use 5, 10, 15, so something like that. And on the vertical axis, we need to use 10, 20, 30, something like that. So I'm going to take the 2 points to be 5. So this is, I'm going to say it in terms of thousands. So the horizontal axis has to be the folders produced. So in terms of thousands. So I'm going to take this as 5 and this as 10 and this point as 15 and this as 20 and 25 and 30. The maximum number we have is only up till 28, so this is fine. And on the vertical axis, so I need to use this 2 centimeter for 10,000 euros. So this is basically the production cost. So the production cost, of course, in terms of 1,000 euros. So, and the maximum cost that we have is 72. So let us draw it up till 80. So it's going to be 10, and this will be 20, and this would be 30, and 40, and this is going to be 50, and this will be 60, 70, and finally we will have it as 80. So now we have to plot all these points. Now, when we think about plotting these points, so this is how it would look like. So the first point is 10, 35. So 10, 35. So the first point would be here. So this is what is my first point, which is 10, 35. And the second point is 15, 40. So 15, 40. So point 40 is here. And the next point is 22, 60. So 20 is here and 25 is here. This middle point would be 22.5. So 22 would be slightly lesser than that. So 22.5, 60 would be somewhat like this. Then we have 30, 72. So 30, 72. So this point would be 75. So 72 would be something closer like this. And next we have 28, 68. So 28 would be something here. And 28, 68. So 68 would be somewhat like this. And finally, we have 21, 55. So this is 20 and 21, 55 is here. So now this is how the scatter plot would look like. And in case if we draw the line of best fit, so that's going to look something like this. So in this graph, so if I think about drawing a line of best fit, so my line of best fit would approximately look something like this. Yeah. So this would act as my line of best fit. And this is what is the right answer for part A. Now, if I talk about part B, And in B part 1, so what we need to do is write down for this set the data mean number of folders produced, which is X bar is what we need to calculate. So X bar is, so this is what we are taking it as X and this is C. So X bar would be equals to the sum of all these numbers divided by 6, so which is nothing but it's going to be 10 plus 15 plus 22 plus 30 plus 28 plus 21. And there are 6 data, so that is the reason. So we would divide this one with 6. So when I do this, so we will be getting the answer as answer which is closer to 21. So that is the right answer for B part 1. So now if I talk about B part 2, so we are talking about for the set of the diagram, the mean population is C bar. So now C bar is basically the population of these points. So that's going to be, which is C bar is equals to 35 plus 40 plus 60 plus 72 plus 68 plus 55 and entire thing divided by 6. So when I do this, so I'll be getting the answer as 55. So next for part C, we need to label this point X bar comma C bar on the scattered diagram. And we got the value of X bar as 21 and C bar as 55. So let us label this one, so which is nothing but 21 comma 55. (21,55). It's exactly here. It is actually the last point, which is basically this one. So this point is what is point M, which is X bar comma C bar. Actually, we can draw the line of best fit in a better way by making sure that it passes through the mean points. So in that case, I can also think about redrawing my line of best fit. So something like this. This would also work. Or maybe something like this. And yes, this is the point we need to represent it on the scatter diagram. Now, for part D, we are talking about use the graphic display calculator to find the Pearson's product movement correlation coefficient. So in order to do that, so let us use our calculator. So on the calculator, so we have to go to the spreadsheet. And we need to type down the given data. So on the first column, so we'll be typing the folders produced in thousands. Of course, we will just put it as 10, 15, then of course, we need to put it column wise. So 10, 15, then 22, then 30, then 28. This is the whatever the values we have it in the first row of the table. So we are putting it in the first column. So now in the second column, so we will be putting the corresponding cost in euros, so which is nothing but 35, of course, in 1,000 euros, 40, then 60, then 72, then we have 68, and finally we have 55. So in the first column, so I'm going to name this as, so these are folders. So I'm just going to name it as folders. And that's for the second column, we know this is the production cost. So I'm going to name it as production cost. So once I have done this, so now what we have to do is we need to do the start calculation. So under that, so we need to do this linear regression. So when I do this linear regression on the X list, I need to choose this folders. And on the Y list, I need to choose this production cost. So once I do this, I'll be getting all the values. So here the correlation coefficient is the value of R. The value of R is nothing but, so this is for part D, and the value of R is nothing but 0.9895. And that is what we are getting it. So 0.989568 or so something. So which we can also round it up to 0.99. So this is what is the correlation coefficient is. Next, if I talk about the next part, which is part E. State the reason why the regression line C on the X appropriate model the relationship between these variables. So now, whenever this R value is very, very closer to 1, so we say it has a strong correlationship. So this X and C, so where X represents the folders produced and C is the production cost, so these things are strongly correlated. Strongly correlated. The reason why it's strongly correlated is the value of R, which is the correlation coefficient, which we got it as, it is very, very closer to 1. So whenever I get 1, it's a perfect correlation. And whenever we get any value which is very, very closer to 1, so we see it's like very strongly correlated. So that means these two variables are correlated. So that is the reason we can say X, a C on X is appropriate model, so which shows a strong relationship between these variables. Now use your graphic calculator to find the equation of regression line on C on F. So we have already used our calculator, and in that one, so the equation of regression line is this one. So it's always in the form of y equals to mx plus c. So it's y equals to mx plus c, but here in place of y, we have this cost, mx plus b in this case, yes. So in place of y, we have this cost as c, and in place of x, in this one, so we have this x itself, which is the number of folders, and the value of m is given as 1.9409, so which we can just round it up to 1.94. Then in place of B, so we have it as positive 14.239, which we can also round it up to 24. And this is what is the equation of the regression line, and which is the answer for part F. So draw the regression line C on the scatter diagram. Now, for part G, we are talking about draw the regression line C on X, C on X on the scatter diagram. And this is what is the scatter diagram is given. And in part F, so we have gotten the equation of the regression line to be something like this, which is 1.94x plus 14.24. So where this 14.24 represents the y-intercept, and that y-intercept would be so something like this. So this point is 15, so 14.24 would be something like this. And we are talking about the gradient of 1.94. So in that case, if I say gradient of 1.94, the other way of plotting another point would be, so we can think about, let's say when x is 10, what is the value we will be getting? So when x is 10, so we'll be getting it as 1.94 times 10 plus 14.24. So when I solve this, so it's going to be 19.4 plus 14.24. So 19.4 plus 14.24 is going to be something around like 33.64. So this is the point we are finding it, because to get another accurate point so that we can plot it. So it's basically 33.64. So 33.64 would be something closer to this point. So now in that case, I could say my regression line should be something like, it would pass through these 2 points. And it would look something like this. And this is what is the regression line, which has an equation as C is equals to, because on the y-axis we have C and on the x-axis we have x itself. So this is what is equals to C is equals to 1.94x plus 14.24. So, and that is the right answer for this sum. Now, use the equation of regression line to estimate the least number of folders that the factory needs to sell in a month to exceed the production cost of each month.